Right. Okay, Budhe. So last week we have started discussing about different matter, basically different things. So which has different status. So some are taking space, and some also having mass and also taking space, and some are some components we saw that those are not having mass as well as those are not taking any space. So we divided fundamentally according to that. So that is, so hope you can remember that was our fundamental categorization or the basic categorization. After that, we were further dividing. After that, we were further dividing. Here it is. So this is what we were discussing last day, right? Under the lesson number 2, we just divide things having mass and not having mass. Also, things like occupying some space and not occupying space. And actually, these are also considered as some other materials. So we learn not materials actually, some other with some, these are defined with some other concepts. But for the moment, just remember the things like the sunlight, waves. These are not having, actually not occupying, it's not getting any space, as well as not having mass. For the moment, you can think about this categorization. But the things around us like pen, water, air, those are having mass and occupying space. We did small practical to actually learn about that. So here you can see an experiment which is used to find whether air takes or air occupy space, right? So to do that, actually you can put a handkerchief in a glass, the empty glass. Just put handkerchief and then keep it parallel to the water surface. Use a water bucket. So just keep it parallel to that. Don't keep it in any angle. Just parallelly move it from top to bottom. So actually we will so initially we will think that handkerchief will be wet because the water will move inside and this handkerchief will it will be wet. So we will think like that. So you have to actually, first of all, you have to make sure that this handkerchief is properly placed in the bottom of the glass, right? Then when we move down, and after that, after some time, you can take it up again. Don't make it, don't keep any angles, because when you keep angle or when you put it like slides, if you slide this or if you move this, other than moving up and down, if you move to the sides or like some angle like this or this, so this handkerchief can be wet. Therefore, don't do that. So just move it directly from bottom to top again. So first you have to move top to bottom, then bottom to top, only this movement. So then you will see the handkerchief is dry. So why the handkerchief is dry? Because water will not touch the handkerchief. Water will not touch the handkerchief. So why? Why water will not touch the handkerchief? Because there is air layer here actually. So let me color this area. In this area, so there will be air. Actually, this is air sealed. This handkerchief is air sealed. You cannot see air, but anyway, it occupies some space and it is protecting this handkerchief from being wet, right? That is why this will be dry. So that is one experiment. The other experiment was balloon experiment. So you have to balance two balloons using a ruler. We learn about the balancing act, how it happens. So basically the weight as well as, let's say, weight W and the distance D. So let's say W1, D1, and here distance is D2 and this is W2. Then we learned that W1 into D1 equal W2 into D2. That is how we balance. We have actually played small game, did a simulation, tried that simulation and learned this principle. So then when you balance like this, right? Then what will happen if you make small hole or if you poke into this balloon? But please remember that. So I have recommended you to put a tape. Why? When you poke into balloon, it might blast. Actually, most of the time it will blast because of the forces affecting the surface of the balloon or the rubber. Therefore, I said that put a sellotape, transparent sellotape, both sides, both balloons, you can put this transparent sellotape, otherwise it will not be balanced again. So when you put a transparent sellotape in both balloons, and then when you poke into, or when you poke it, or when you make a hole, it will not blast. But when you release the air slowly, the balloon without the hole will move down. That means the weight here will be greater than this because the air is going out. So that practical also we did. That is proving air have a mass. This is proving air occupy space. We did that 2 practicals. Then we learned how to measure this using measurement units. So basically kilograms, grams, milligrams. So these are some measurement unit, and we learned the relationship among these measurement units in that. Right? Then after discussing this, so the things get in space and also having weight, we have further categorized into this status of matter. So basically, if it occupies space, and so 2 things. So what are they? So solids. What are the things we can see, or what are the properties we can see in solid? Yes, can you remember? Things we can see in solid. Is it occupying space? Let's say space. Is it taking any space? Solid things. Hello? Can you hear me?
Yes, sir.
Okay, solid. So can you tell solid, is it taking some space? Solids?
Solids, it can space.
Yes, it can take space. Is it having mass? Is it having mass? It's taking space, correct? Is it having mass? Solids? Hello?
Yes, sir.
Can you hear me clearly? Or is it something? Am I lagging, or is there anything preventing you hearing me properly? Is something? Can you hear me properly?
Yes, sir.
Okay. මට කියන්න solid වලට space එකක් ගන්නවනේ. ඔයා කියවන space එකක් ගන්නවා. mass එකක් තියෙනවද? බරක් තියෙනවද solids වලට?
Oh, sir.
Oh, it's getting mass as well. Okay. Remember these things, right? එතකොට mass එකකුත් තියෙනවා, කියන බරකුත් තියෙනවා, space එකකුත් ගන්නවා. And also another thing, the shape, it has a shape. හැඩයකුත් තියෙනවා, right? It has a shape. Shape එකක් තියෙනවා, හැඩයක් තියෙනවා. ඒ වගේම mass එකක් තියෙනවා, බරක් තියෙනවා, space එකක් ගන්න. ඒ තමයි solid. Liquids ගැන හිතන්න. Is it taking space? Space එකක් ගන්නවද? Liquid like water, is it taking space?
Yes, sir.
Yes. Is it having mass? Water, is it having mass? බරක් තියනවද වතුරට? ඔව් නේද?
Yes,
It's having
sir.
mass as well. So is it having a shape?
No, sir.
No, it's taking the shape of container. එයාගේ shape එක එයා දාලා තියෙන container එකේ shape එක තමයි එයා ගන්නෙ. So okay, that is how we identify the liquid. The third one, right? So this gaseous state or gas. Yes, I also change. I think this power issues are affecting you, right? Okay, gas. Is it taking mass? Is it having mass? Is it taking space? It's having mass, yes, it's having mass. And it's taking space as well. But is it having shape? No, not at all. So it's not having any shape, right? Those are the properties of these three matter, status of matter. So this is according to the status of matter, right? Okay. So let's go and write down these properties quickly. Right, I explained this using water cycle last day. So it is possible to convert one format to another format. There are things converting. So you can see with this image, it is nicely explained. So water, after evaporation, it will become gas. And so after condensation, it will become liquid. Evaporation කියලා කියන්නේ වාෂ්ප වෙනවා. Condensation කියලා කියන්නේ ඝනීභවනය වෙනවා. හරි? ඒතර වාෂ්ප වුණොත් after evaporation it will create gas. After condensation it's creating liquid back. Okay, you can test that. So when you are when you are inside a glass house or a vehicle, when it is raining outside, so what will happen? If you turn off the AC, when it is raining outside, and when you turn off air conditioner, what will happen inside? Right, I think you have seen this. Rain without AC inside vehicle. So let's search inside car. What will happen if you don't have AC? When there is rain, you can see this kind of thing. Haven't you seen this? I hope you have seen, right?
Yes, sir.
That is what? That is a result of
Water vapor.
yes, condensation. That is water. That is result of condensation, right? Evaporation means the other thing. When there's a liquid, when you boil it, especially when you boil water, it will evaporate. Or due to the sun, right? Due to the sun in the noon, especially. So in the water surfaces, actually this water evaporate, right? It emits as gas. Then, so another thing, if you freeze a liquid, it will become solid. So remember that how you create ice in your refrigerator. When you put a liquid into this ice container or the container, and if you put it in the freezer, it will become ice, solid. The liquid can become ice because of freezing, but when you take the ice and keep it aside, keep it exposed to the room temperature, slowly it will become liquid. Or that is melting. Ice cream, take ice cream for an example, it's in the solid state, but when you keep it for some time, it will melt and become liquid back. And the another thing is solid can right? Solid can sublimate. Sublimate in Sinhala we call Urdhava Pathanaya, but that no need to learn that word. So maybe a bit difficult. Sublimation means a solid will become gas. So solid will become gas. So that can also happen. A solid can become gas. And the other thing is a gas can become solid with some pressure and with high pressure and cooling. So that can become solid again. That is called deposition. So this is rare. Maybe you have not seen, right? This is rare and maybe you have not seen. Sublimation is when solid become gas, and deposition is when gas become solid. Okay, so let's learn about these. This is explaining about state of matter. And you can see this is what I said. The light, sunlight, right? The waves, it is considered as plasma, right? But no need to learn about this plasma thing for the moment. Let's learn about solid, liquid, and gases. Solid, liquids, and gases. Okay, solid. So please write down. So write down the main heading: status of matter. Status of matter. Please write down that heading: status of matter. Status of matter. STATUS, status of matter. Then please write down the first thing, solids. It has a definite shape. So I think better you write down the full sentence, but so just to explain, it has a shape, that's a definite shape. So in the examination also you can write down solids. So it takes space, right? Takes space. It has mass, and that it has definite shape. Okay, please write down this as well. Sorry, let me add this. Let me edit this. Sorry. Take up a fixed amount of space having mass, right? It has mass also, but this is common to all three: solid, liquid, gas, all three having mass, and it will take space. So no need to write down repetitively. That's why I skipped anyway. Please add that as well. Please write down this. It has definite shape, having mass and taking space. Generally, right? Not able to compress. Not able to compress means, so that is generally, but in the special cases, there are methods of compressing. Compressing means the space taken by the device cannot be changed, right? Generally, but there are special occurrences where you can change the space, but normally you can't change the space taken by the device. You can just explain that here. It's in the brackets. Space taken by cannot be reduced. So that is called compressing, reducing the space taken. So space taken cannot be reduced. Please write down and let me know once you are done. Right. If you are done, let's move to the next one. Okay. Finish it now. Take your time and finish it. So it has a definite shape. It's taken a fixed amount of space, having mass, and not be able to compress. It is not possible to reduce the size or the space taken by the component generally, because those are solid.
Writing, sir.
Finish. Finish or
Yes, sir.
okay, let's move to the next one. Right, that is about solids. And let's see the facts about liquids. Right, so the basic property is the shape changes according to the container. So that is for sure, the shape is changing according to the container and it's taking a fixed amount of space. Right, the shape is changing and it's taking the fixed amount of space, taking fixed amount of space too. And also having mass, so actually you can add that too. Having mass, it also. And for liquids also, normally we can't change the space taken. For liquids also, we cannot change the space taken. Normally, under the normal circumstances, difficult. Right. We learn about solid and liquid. The third is gas. That is the third status we need to focus. That is the gas. That is gas. Okay, in gas, you can see, so it will not spread out and will not stay in the container unless it has a lid. Right? When it is fully covered, it can take the container. It can fill into the container if it is fully covered. Otherwise, it will not stay. But water, it can stay even without a lid. It can stay. If you are not moving, even without a lid, it can stay. But here, see what's happening in air or gas. It's moving out. You have to seal it. It's moving around and taking up all the available space. So let's say you put gas into a large room. It's taking the entire space of the room. If you put the same gas into another container like a balloon, it will take the space of balloon. If you try to compress and put that into another kind of container like a tin or something, it will take that state. That means it can be compressed. It can be compressed. So here I need to add that it can be compressed. Right? It can be compressed means the amount of space taken by the gas can be reduced. Anyway, it's moving here and there everywhere in the containers. That is called diffusion. So it's moving here and there. හැමතැනම යනවනේ භාජනයේ හැමතැනම පැතිරෙනවා. ඒක ලොකු එකක් නම් ලොකු එක වටේට යනවා. ඒක පුංචි එකක් නම් පුංචි එක පුරාම පැතිරෙනවා. දෙන ස්පේස් එකේ හැමතැනම යනවා. That is called diffusion. And it can be compressed. Please write down this. There are two C's. Please use only one C, right? Compress, it can be compressed. It's only one C. Let me cut. This is not needed. Just write only one C. That is enough. Okay, please write down this as well. Right, now we know all three status. So let's see some other properties, as I said in the beginning. So how to change these status, right? How to change this status, except the boiling point. So I think we can discuss the other things today. So we are going to learn about melting, freezing, condensing, boiling, evaporating, melting. So another thing, so sorry, I couldn't add this to, that is sublimation and deposition, right? We are going to learn about freezing, melting, condensing, boiling, right? Freezing, melting, condensing, boiling, evaporating, sublimation and deposition. We are going to learn about them. Okay, melting. I think this image itself giving you the note. So it's very easy to remember. So this is image of ice stream. Hope you can recognize. When you keep ice stream for some time in the room temperature, it starts melting. The reason is ice stream is it's maintaining its status as solid when it is freezed, when it is cooled or freezed. Inside the freezer, it has its solid status. But when it comes out, when it is exposed to the room temperature, so what will happen? It's a solid, it will become liquid. So we call that melting. So what causes this? What is the reason? Why solid become liquid? The reason is, yes, what is the reason? Why solid become liquid? Melting is when a solid become a liquid, we call that melting. Why it happened? So what's the reason? Main reason is, come on, what is the main reason? I solid එකක්. ඇයි මේ ඝන තත්ත්වයේ තියෙන එකක් ද්‍රව වෙන්නේ? ඇයි දිය වෙන්නේ? Ice cream දිය වෙන්නේ ඇයි පුතේ? So why ice cream is melting? Sorry?
Because it is in a hot temperature.
Yes, because of the temperature, because of the heat, right? That's the reason. Okay, please write down this. So one is melting. Melting. So then please draw this. Melting means solid. When solid become liquid, it's called melting. When solid is converted to liquid, it is called melting. The reason, the main reason is heat. Okay, finish.
Yes, sir.
Right.
No, sir.
Oh, quickly write down. So only few words: solid, melt, heat, liquid. Solid become liquid, that is called melting. The reason is heat.
Finish writing, sir.
Okay. So this is what happening. I said that everything is made up with some substance, right? Some kind of thing. So these are basically atoms. Right? Initially, the tiniest, the smallest unit, we call that atom. Anyway, right? What will happen when solid has this consistent? So it's also moving, but the thing is, so due to this shape, it's preserving the shape. These units cannot move here and there. But what happens when become a liquid? It can move rapidly. It can move rapidly. That is why it takes the shape of, the container, because it can move. But here very less movement. So it's minor, or actually you can call no movement at all. But here you can see it's a rapid movement. So then freezing. Freezing is the other side of melting. That is also called solidification. Freezing or solidification is other side of melting. That means liquid will become solid. So what's the reason? What is the reason why a liquid becomes solid? Why water become ice?
Because of the temperature.
Because of the temperature, again, because of freezing, because of the cool temperature. Please write down freezing or solidification. The reason is because of the cool temperature. So please write down that now. Next is the reason why this is happening. So similar to the previous one. So you can see these atoms or these units or maybe these substances made up with the particular liquid is moving rapidly. It can change the position. But the thing is, when it becomes such fixed thing, you can see the shape is unchanging and the movement is very, very, it's like unnoticeable movements or very small movement. So it's not changing the shape. But here the movement changes the shape. That's the reason why. Okay, the third one is evaporating. That you know. So when you boil, right? When you boil something, what will happen? When you boil a liquid, evaporation happens. So basically, that is where, right, the liquid become gas. Evaporation. So please write down the liquid become gas. For an example, think water. When you boil a water jug or when you boil it, it will become steam, right? It will become gas, or H2O gas, water gas. That is what, when you steam you are doing that. No, when you want to steam, you boil the water, right? Then the steaming means it's a gas that is basically evaporating water. It's a liquid. When liquid become gas because of the heat, we call evaporation. Please write down that. The reason is, right, you can see, as I said earlier, this is the container, this is your liquid. Liquid has taken the shape of the container, but when it become a gas after this evaporation process, it's moving everywhere in the container. It's moving everywhere in the container. We learned that. Right. So then the condensation. So that is also very important. Condensation. Condensation means when this gas become liquid back again. The gas become liquid. Why? The reason is again the temperature. When you cool down, the gas will become liquid. When you cool down, gas will become liquid back again, right? So that is what happening in the clouds. When these clouds, so when it cool down, it will become liquid again, and that will cause rain, right? Okay, these are very simple things, but only thing is you need to remember the terms, names, because that is what asked in the examination. Okay, please write down these two. Right. Thing is, Okay, we learn about condensation now. So the reason for condensation is when this gas is there, when you cool down, what will happen? The movement will be slowed down, and it will only take in like, so these substances will be closer enough to take the size of the container, to shape of the container. So it's not moving everywhere, it's just moving in this. Okay, then sublimation. Sublimation, actually, it's a kind of a rare thing, but still, if you have seen, okay, some actually in Sri Lanka, in some wedding functions, this sublimation is used. Have you seen dry ice in weddings? The dry ice. So basically, it's used in that the milk pots. It's used in the milk pot function or milk pot. There is a event in the weddings. So in Sinhala we call kiri kala. Have you seen? No. Oh yes. Dry ice means actually the carbon dioxide. It's a solid state carbon dioxide which is frozen. So it is actually solid. When you put carbon dioxide into, when you put water into this carbon dioxide, or this carbon dioxide solid into water, it will become gas. Immediately it will become gas. This is example for sublimation. Have you seen that? No. Oh yes.
No, sir.
No. Okay, let me show you this dry ice experiment. If dry ice can be created using this, fire extinguishers. Using fire extinguishers are using fire extinguishers also, it's possible to create dry ice, right? So when a fire, fire extinguisher, so when you use a cloth and then open this fire extinguisher, in the cloth, due to the pressure and all, there will be dry ice collected in the cloth. That dry ice, you can put it into the water. I'll show that, right? Fire extinguisher, dry ice. So you can do the experiment, but with help of adult, right? This is not dangerous, but you can do this with the help of an adult. Okay, let's see this. Okay, our fire extinguisher kattama yatak gale mewa karane. You can see. This is a fire extinguisher. It's just removing the seal. After removing the seal, he's putting a cloth to cover this. Otherwise, you can't collect that. Then he sprays that. When he sprays that, inside the cloth, so actually this cloth is there as a bag, no? Inside this bag, carbon dioxide solid will be collected. It's white color. It's called dry ice. It's called dry ice. Really ice killer. So you can see it's evaporating, right? Not evaporating, sorry. It's sublimation. Sublimating means this solid will become gas. Can you see it's smoke? It's generating some smoke. It is where the solid will become gas. Even after you put this, you can see some gas coming out from that. So that is basically sublimation. When you put water, this will be expedite. This will be faster. If you put water, it will be faster. Okay, they are putting water. And after putting water, you can see the process will be faster. That is what sublimation is, right? I hope it's clear now. Okay, let's move to the sublimation is when solid become gas. The reason, as you expect, this substances or the atoms, whatever it made with, so when it become, when there is a distance, right, it will become gas. Okay, then this practical part, I think we can do that next day. So with that, I'll stop for today. We'll discuss the remaining part next week. Then good night. See you all next week.
Good night, sir.
Bye.
Thank you, sir.
Welcome.